Hello everyone, my name is Marie. I'm here today with Engineering Outreach Department to give you guys a little activity, and today we're going to be talking about 3D modeling. So, before we get into it, I kind of wanted to talk about, first of all, what you do as an engineer with 3D models. What's the point of having them? So they're mostly used by mechanical engineers, and that's very personal to me because I'm a third-year mechanical engineering student, so I use 3D models very, very often in my classes. I've got a lot of practice with them, so I'm very excited to talk to you guys about it today. So, first of all, what does a mechanical engineer even do? What do they work with? What are these models being used for concretely? So, a mechanical engineer is someone that works with any type of power-producing machine. So, if you think about turbines or generators or engines, gas turbines, that type of thing, that's going to have been designed by a mechanical engineer. So that also includes whatever is refrigeration or heating systems. So inside your very own home, there's definitely something that has been designed by a mechanical engineer, not only in your car or in those high-powered vehicles, but also in your day-to-day life, like your fridge. So it's really a domain with a lot of different applications and a lot of different concepts that are brought upon. And we often need to use 3D models. So to make 3D models, we'll be using this type of software that we usually call CAD. So CAD software is for short, which means computer-aided design. So it's a software technology that allows us to create objects or mechanisms in 2D or 3D so that we can analyze them and really see if we can actually make them. And they allow a lot of precision and help kind of make the process more efficient. So with CAD, engineers can explore different types of design possibilities without actually having to physically make the thing, which can save a lot of resources, a lot of time, and a lot of mental stress as well. So CAD really is super useful in general in the mechanical engineering area, but also in any type of product creation or solution making that includes an object or a mechanism that needs to be kind of troubleshooted before actually creating it. So that's what we're going to be using in engineering or in other departments for innovations that are a little bit safer than the we'll do it in real life first approach. The other thing that comes with 3D models that is super useful and also very fun is 3D printing. So once we have a 3D model, it can be used for a bunch of different things. We can use it when you think about like video games or movies, those are all 3D models. But we can also use it to print. So this creation that we've made on our CAD software, we can actually use a 3D printer and print it. So 3D printing is really useful because it's so flexible. We can really print whatever we want to design. Once you've created your 3D model, you just send it over to the printer and it'll be able to print whatever you've created, as long as gravity allows it. Because 3D printing uses a method of printing that prints layer by layer. So a 3D printer will have a type of filament attached to it, which is usually PLA or some kind of plastic, that goes through a nozzle that heats it up really hot. Usually nozzles are around like 200 to 300 degrees Celsius, which is a lot warmer than an Ottawa summer day. So it is very warm in there, and it'll melt the plastic that's coming in through this filament so that it becomes kind of malleable, kind of soft. And we'll be able to put down layer after layer of this plastic to finally create something. So obviously when we're printing something, we have to take into consideration things like gravity or the weight of the object or the weight of the filament, that type of thing. But otherwise, it's pretty limitless. The only thing is it takes a lot of time. So 3D printing is really cool, but if we want to 3D print something that's very big, it will take us hours upon hours. Small prints, if they're pretty simple, can take up to like between 20 minutes to an hour, but it can easily go way over that when we're printing something that's more complex or something that's bigger. So, in order to use this printer, we need to first create our 3D models. So usually at university, we'll do projects and we need to come up with a solution for a system or something. And our first step will be to go through a modeling phase where we'll use a CAD software, so computer-aided design, in order to create our solution and test it out on a variety of different softwares, make sure that it can take X amount of weight, that type of thing. And once we've found our real solution, we can print our prototype using a 3D printer on campus. So today, we're going to be doing something a little bit more fun with our 3D printing, and we're going to be 3D printing we're going to be modeling the race cards. Unfortunately, as I said, 3D printing takes a lot of time, so we'll be focusing on the modeling today. If you're following along though, you can absolutely save your file and print it as you'd like. So we're going to be using a website called TinkerCAD. I'm just going to switch my screens over so you can see a little bit more. So this is TinkerCAD. TinkerCAD is more of a base level CAD software, so that's what we were talking about, a software that allows 3D modeling. And it's really handy because it's easy to understand and still has a decent amount of freedom and flexibility when it comes to things that we want to create. So if we go over and log in, if you guys already have an account, you can log in, and if not, you can create one. So I'm gonna go ahead and while I'm logging in, for you guys that might be in a classroom, it's really easy to create classrooms with TinkerCAD. It's a super handy, nifty trick, and you can just create a classroom through TinkerCAD, and then that way everyone can have access to the general files. So when you log into TinkerCAD, this is usually sort of what you see. It's a little bit different because we've got a teacher account, so we can actually see the past classes that we've made. But for now, we're just gonna head into our designs. So on the designs, you'll be able to see past designs that you've created, or and you'll be able to edit them if you'd like as well. And when we click over on create, we've got 3 different options that come up. So we've got 3D design, circuits, or code blocks. So TinkerCAD is a really interesting software because it also allows to do different types of like troubleshooting or simulations that include circuits or code blocking. So if you're looking for a software that can not only 3D model but also build circuits and also do some coding, TinkerCAD's perfect because it's got all that locked in. So, as I mentioned today, we're going to be focusing a little bit more on the 3D designs and 3D modeling. So we're going to go ahead and pick the 3D design option. And once we've picked the option, we're going to come to this area here. So this area here has our work plane at the very center. This grid here, you're able to select things, move around as well. If you're looking for specific views, you can look over at the top left here that has this cube, and you can actually just click on these different views if you would like to see from this area, from these views. You can also click and drag on the cube in order to move around the space. You also have the option to zoom in and zoom out. So, right of that, you'll have all these different options, and the first thing that comes to mind when you look at this is pretty much all these different shapes, because they're very bright. We've got a lot of colors, a lot of different shapes, and these are kind of the base shapes that TinkerCAD offers. They're the ones that we're going to be looking at today. However, if you come up to the options tab here, you'll see that TinkerCAD actually offers a lot more different shapes, including creatures and characters, which is my personal favorite. But so over top of these different types of shapes, we've got here these 3 little options that do different things. So first of all, we've got notes. Pretty self-explanatory. We can leave notes on our 3D work just to remind us of dimensions or things to keep in mind. Our ruler here is very important. So this one, I'm actually going to click on it and drag it all the way onto the work plane. and just set it in a corner. It can go anywhere, it doesn't have to be the corner. I like it in the corner though. And this ruler is actually going to make us able to keep track of our dimensions better. So it's really, really important when we're doing 3D modeling, or if we want to do any type of 3D printing, to take into account what units we're working with. Because if we're kind of arbitrarily picking dimensions and kind of doing whatever we want, and we don't know if that side is 90 centimeters, 90 millimeters, or 90 apples, it won't work. We won't be able to succeed in making our 3D model, and we definitely won't be able to succeed in printing it. So it's really important to put this ruler tool down so that we can keep track of the dimensions. In this case, it's going to be millimeters. And then over here is just the work plane tool. So just to show you an example, if I were to take off this ruler, if I were to delete it from my space, and I dragged a square in, I can see dimensions if I'm hovering over these different points, but they don't mean anything. They just kind of mean an arbitrary 5 or an arbitrary 19, an arbitrary 29. They don't actually mean anything. Whereas if I put my ruler in, oh, sorry about that. I'll just go back on there. So we saw those numbers there that just kind of seem like they don't mean much. Every time we move it, we've got that arrow that appears that tells us how far it is from the previous point, but that doesn't really mean much at the end of the day because those numbers don't mean much. Whereas if we drag the ruler in, it wants to let me this time. Oh, there we go. If we drag the ruler in, we will see that all of our dimensions pop up, and this distance here is given the distance in comparison to this point here. So the reference point is not constantly changing, it is always the same reference point, which is really important. And once we click on our object, we can actually see all the different available dimensions. So it's a lot more precise, and it'll be a lot more efficient when we're changing all the different dimensions. So if we look at our cube, we see we've got these 4 dimensions here, which is kind of odd because we've only got 3 dimensions, right? So why does this cube have 4 dimensions? So this first one over here is going to be our width. So this width, if I change it to a 50, it'll make our cube very wide. Our length here, if I make it 50, our cube will get a lot longer. And then over here, our height is going to make our cube taller. This 4th dimension here is actually really handy because this 4th dimension is going to allow us to lift our cube off the plane a certain amount. So if I were to put a 25 here, my cube was going to be off the plane, just floating. So, you might be wondering, what's the point of making the cube float? Why would we ever want something that's not on the work plane? This will be impossible to print. It would be. This cube would not be able to print, and the 3D model itself is just kind of useless because it's a cube, but it's floating a little bit, so not really helping us out much on that front. But this height, we'll be able to use it during the making of our race cars in order to move blocks around and blocks that are resting on others. So it'll make more sense once we get to it, but that height, that 4th dimension, is actually going to be very useful. That said, that 4th dimension is not actually a 4th dimension. It is just a movement along the Z axis, so the axis that's coming out of this one, because we've got our X and our Y over here, and our Z is the third one going up. We are still very much in 3D, we just have this fourth option here in order to raise our square. So I'll take it out. So our first object that we're going to be putting in is actually a cube. So I will put my cube down right over here. Sorry, I need to blow my nose. Sorry about that. Okay, back to it. So we have our cube here. So the first dimensions we're going to put in is we are going to change our width to 90. And, oh, I lied actually. This is going to be our width over here. So we're going to change that to 90. So we should have a 90 by 90 right now. And this second 90 over here, this is actually going to be our length. So we're going to change our length to 25. And our height as well to 25. So we should have a nice little rectangular 3D shape with, once again, the dimensions being 25, 90, and 25. And we leave this fourth option at a 0. So now we just need to make sure, as we're making a car, that the top is not absolutely flat because we want it to be somewhat aerodynamic. So we're going to go ahead and pick the half circle option, this one right here, and we're going to put it onto our work plane. And this one here, we're going to change these. We're going to put our width here to 25, our length to 90, and our height is going to stay at a nice 10. So we want this on top of this, right? So that's where our fourth option is going to come in and be really useful. So if we click over on our 0, 0, we'll be able to move it up to fit on top of our rectangular 3D shape. So, as we said, we've got a height over here of 25. That means we want our 0, 0 here to be changed to 25. And now, we want it to fit over lengthwise, but it's not looking like it's going to work too well. So, we have the option here to rotate. So we've got other options to rotate. We can rotate around all the axes that we want. So we don't want to rotate it this way, so we'll leave it there. We want to rotate it around here. So we're going to put it at a nice little 90 degrees for our right angle. And we can sort of place it where we think it's going to go, but it's never going to be perfect. So I'm going to put it a little bit off just to show you guys what the next tool that we're going to use is really going to help us do. So right now we've got it at the height that we want. We've got our half circle at the height that we want, but it's not at all in the right place. So what we're going to do is we're going to select these two shapes and we're going to go over to our option top right here that says align. When we click on this top shape, we're going to have these different little dots that appear. And this is going to allow us to align our objects along different planes. So if I hover over, we'll be able to kind of see what different alignments we could do. So we can align it all at the top, but if we're looking at the little preview, it doesn't look quite right. Doesn't look like it's what we're looking for. Same here. That's looking better. But right here doesn't look quite right. So what we're actually going to do is we're going to pick the middle one here as well as the middle one there. and that's going to allow our objects to align with the X and the Y, and they will be perfectly right on top of each other. If we wanted to move around with these, as you can see, not exactly what we're looking for, so we're going to leave these 3 dots alone, and now we have our perfectly aligned base for our car. So our next step, still keeping in consideration that we want it to be kind of aerodynamic, we're going to go ahead and pick the wedge. So just give me a second here. There we go, the wedge. So our goal here is we're going to try to create kind of a diagonal line along here so that our car is sort of aerodynamic, right? So this wedge is kind of going to be our line. So the way we're going to do this is we're going to do a little bit of rotation here to make sure that we've got the line that we want. So we're going to go just about at 45, I believe. Yep, half a right angle. And there we go. And now we'll be able to freely kind of play with the dimensions to see what angle we want to be at. So let's see. I'm gonna want this to be a little bit taller, but I'm not quite getting the wedge that I want just yet. So I'm gonna keep making it a little bit taller until the point of my wedge is sort of aligned with the top. Doesn't have to be spot on, but just a little bit. Okay, and once I'm here, I'm just gonna make it go out a little bit more. And then I'm gonna move it in so it's really through the shape that we've made. So it's really like that. So for this diagonal line that we want going through it, you can really kind of freely move around with the dimensions. Just make sure that our point of our wedge is just above the shape that we've created so far, because otherwise we'll have that weird kind of point into our race car, and we really want it to be aerodynamic. We want to get that complete diagonal line so the air goes right off it. But we're looking at this and it doesn't really make sense, right? How is this gonna give us that diagonal shape that we're looking for? This just kind of looks weird. We've got this huge like triangle going on at the bottom of our race car. So we're actually going to change this object from a solid into a hole. So when we do that, it's going to take this kind of like see-through color or see-through opacity, and we're actually going to be able to see sort of where it's going to cut in. So we're going to see that this whole area here that's grayed out is going to be cut by this wedge that we've created. So in order to cut it, what we're going to have to do is select everything again. And we're going to use not the align option this time, we're going to use the group option. So it'll be the second option from the left at the top right of your screen. And when we click on group, it's going to go ahead and cut it. So now we've got more of that shape that we're looking for that's really going to allow us to make that race car. If you want to keep the different colors, you can absolutely do that and just go ahead and press multicolor and we'll get those two colors back. I'm going to want to keep it in red, maybe an orange. Yeah, orange sounds good. and I will keep it that way. So now we've kind of got the body of our car, but we're missing our seat. So in order to make the seat, we're going to go ahead and grab the semicircle one more time and just put it down on the work plane. And this time, again, the dimensions aren't super set. You can pick whatever you want dimensions-wise just to make sure that it does fit. So we're going to need to, first of all, go ahead and rotate it upside down. So a whole 180. And then we're just going to move it. Oh, oopsies. We're just going to go ahead and sort of move it around. Make it maybe a little bit longer, a little bit wider, however we want. And we're going to want to go ahead and raise it as well so that it's kind of floating like this right above. Make it a little bit longer on this side. So you can place this seat sort of where you want to place it. And don't worry about the dimensions too much. As long as it looks like the type of seat someone could sit in, that'll do just fine. So I'm going to make mine a little bit deeper. I want to be safe in there. And just make sure that it's nice and safely on top. Again, we're looking at it, and this doesn't really make any sense, right? This doesn't look anything like a seat. Doesn't look like you're going to be able to sit in it. You're going to be able to sit on it. Kind of looks more like a plane right now, if anything. So we're going to do the same thing that we just did with the wedge. We're going to select our semicircle, and we're going to turn that into a hole. Once it's a hole, you'll be able to see the dark grayed out area is what's going to get cut out. So we'll select everything again, and we will use the group option once more. And now we've got a seat for our car. So right now, to me, there's one thing that is very, very obviously missing, and that's wheels, right? We can't go very far without wheels in general. So we're going to have to go ahead and add our wheels. However, to add our wheels, if we want it to really work and be able to take off our wheels, put them back on once we've actually printed this piece, we need some nuts and bolts. So TinkerCAD doesn't actually have in these shapes the nuts and bolts that we're looking for. They might have some interesting things in hardware. However, what we're going to do is we will actually have the option to just search up nuts and bolts TinkerCAD. So in order to find the one that I found over here, you can just go ahead on Google and search up nut and bolt TinkerCAD. And you will have a whole bunch of options, including videos on how to do it yourself, but of templates as well that have been created either by TinkerCAD staff or by other users that are free to use. So for example, we've got this one here. And this is the one that I'm going to be using today. So these templates are very, very useful, and we can just go ahead and download them. You'll have the option here to pick different types of files. Sorry, I'm going to go ahead and blow my nose again. I'm so sorry. Sorry about that, folks. So as I was saying, you have different file options. So usually if you're 3D printing, you can either use STL or OBJ files. Traditionally, at the university, we generally use STL ones as they're compatible with the software that we use to 3D print here. And we also have the option of files for laser cutting, obviously very exciting, but not what we're going to be doing today. So we can go over here and pick STL, and we'll be able to save it onto our downloads. So once that's been downloaded onto your computer, you can go ahead and go back into your work plane, your TinkerCAD design, and you can actually import 3D files. So we're going to go ahead and choose the file from our downloads, which is nuts and bolts. And here we'll be able to pick the units, the scale, and the dimensions. So obviously these dimensions will probably have to be played around with. We can absolutely do that in the work plane once we kind of get more moving on how big we want our wheels, where they're going to go, that type of thing. So I'm just going to go ahead and click on import. And oh, there we go. So it might take a little while, but it will appear on your work plane. Obviously this is huge. We don't want our nuts and bolts to be that big. So once we've got them, we can move them around. As you can see, they're connected, but that will be a problem we can solve in just a second. So we definitely want these to be way smaller. So we should be able just to go ahead and change the dimensions as we like to kind of fit what we want. So in order to be a little bit more accurate, I'm just going to go ahead and delete them and import them one more time. And just to be safe, I'm going to change the scale from here. So those were a lot too big, and we can see the dimensions there at the bottom. I want them to be a lot smaller, so I'm going to go with a 25% scale, and that's just going to scale it down by to 25% of its size. So we'll just have to wait a second, and it will be loading in. So it's really important to make sure that you're never printing objects that are too big, or it might get a little bit difficult. So there we go. Now we've got nuts and bolts that are a lot smaller. But again, I think that might be a bit too small. So just going at it with trial and error, I'm gonna import them once more, and this time I think I'm gonna go with a safe 50%. And we'll just have to give it another little wait. And there we go. I think that looks pretty good for the size that we've got. Doesn't look too bad. So we've got our nuts and bolts. I'm just gonna make them a little bit of a lighter color so we can really see what we've got going on here. So our nuts and bolts are stuck together right now, and we know we're gonna need a pair of them. So we're gonna need 2 pairs of nuts and bolts. So we're gonna go ahead and we are going to copy it. So we've got 2. However, as I said earlier, they're stuck together, so that's not super helpful. We're going to need to delete either the nut or the bolt off of both these pairs. So to do that, what we're going to do is we're actually going to add a shape as a whole on top, whichever one we want to delete. Oh, why is it doing that? Okay, so we're going to add this hole on top of the nut for that, and then we're going to add this hole right here. And there we go. So once we've done that, we can go ahead, select our first pair, select group, and second, same thing for here, select group, and now we have our separate pair. And we can go ahead, and one more time we are going to copy paste it. So now we have 2 independent nuts and 2 independent bolts. All right. So we are going to want to use these nuts and bolts to fasten in our wheels. So we're going to have to make holes through these, this casing that we've created in order to fit our wheels. So the first thing we're going to do is we're going to add a cylinder into the space, and we want this cylinder to have a diameter that's slightly bigger than the hole of the nut. So we want it to be slightly bigger than this right here. So for that, once again, we can't be exactly precise with it because we don't have the precise dimensions, but we can just go ahead and kind of move around our cylinder, make sure we've still got a base that's equal coherent diameter, and I'm actually going to place it in here to make sure that we've got something that's definitely bigger. So by these dimensions, 7, 7 should be fine. So now we have our cylinder that has the correct diameter. So now we're going to want this cylinder to fit through the base of our car, right? So we'll go over here, we'll zoom out a little bit so it's a bit clearer, and we want this to go through our car. So we're going to make it a little bit longer, and we're going to flip it by a 90 degrees. Once we're done, we'll be able to bring it back down and move it through our car. So we've got to place it kind of where about we'd want the center of the wheels to be. So I'm going to put it a little bit higher. And there we go. So as we know, we want 4 wheels, right? So we're going to have to make 2 of these cylinders and make sure they're aligned. So I've placed one of them. I'm going to go ahead and copy that one. And I'll move the second one down near where the seat is. However, right now there's no guarantee that our 2 cylinders are equally on the same line. So we're going to select both of them, and we're going to go ahead and go into our align option. And this time we'll be able to align them along, it should be one of these 3 dots. So as it happens, they are aligned at the moment, but if I were to unalign them, oh, whoopsies, just move this one up a tad, and I went into the align function, we would have to pick whichever dot you want them aligned with, and they would be aligned that way. So go to align and pick whichever line you want them aligned with. So I wanted them a little bit lower, and there we go. So now that we've got our 2 cylinders aligned and making their way all through the base, we can go ahead and change those into holes. So we'll select them both, and we will change them into holes. And as we've done before, we select the whole thing and we use the group option to make our 2 holes. So now we want to have 4 different nuts. So we're going to take our 2 nuts here and select them and give them a little copy. So now that we've got our 4 nuts, these are going to help us make sure the wheels stay in place. And we are going to want to place them kind of against these holes that we've created, but flush with the surface of the car. So what we're going to do is we're going to select this. We're going to give it a flip of 90 degrees. And so we're going to make sure that we move them so that they're flush with the wall, but that the holes are aligned. So we're going to be moving this to make sure that it is aligned with the hole in the cylinder. So that's pretty good. We're going to do the same thing over on this side. So we're going to flip the nut and we're going to do the same thing once more. I can get it to, there we go, that'll be more efficient. And we put it flush against the side and we raise it up until we've got it kind of centered. There we go. And we're gonna do the same thing on the other side with our 2 remaining bolts. Just zoom out a little bit. There we go. And once more. Now don't worry about perfectly aligning them on both sides because we are going to use the align tool to make sure that they're okay. Just for now, just place them, make sure they're flush against the side of the car. And we can go ahead and flip this one as well. Oh. There we go. I don't think I got quite the right angle on that one. I'm just gonna have to go ahead and give it a little bit more of a flip or a little bit less. Oh. Okay. So this one is giving me a little bit of a hassle, so what I'm going to do, I'm going to take that one out, and I've still got them copied, so I'll be able to bring it back. Now this time I won't mess up. I'll do a 90 degrees, and there we go. And we'll go ahead with what we did for the others, flush against the side, and then raise it up. And there we go. So we want to make sure they're aligned, right? So we're going to go ahead, we're going to select our bolts on either side. And just make sure that we're aligning them along here. And we'll do the same thing here. We'll select one, and then the other. Oh, there we go. And we will align them along there. And there we go. So now we have the perfect fittings for our bolts. And now we can place them just right inside. So we'll flip them over, just as we did, 90 degrees, and they should be able to fit perfectly inside the hole that we've just created. So it looks like it's not quite long enough, so I can just make it a little bit longer over on that side. And I will do the same on this side. So when I'm making it longer, unfortunately it will change this shape that we have around here, called a fillet. It will change it. So if you were to 3D print this piece right now, we wouldn't be able to fit these bolts with these nuts, as I have just changed the shape of them. However, for the sake of the exercise, I will be making them longer just so that you guys can get a final view at the end. But this particular file would have kind of a hard time as the bolts and nuts would not fit into each other properly. So now that they're there, we can finally add in our wheels. So our wheels, we're going to go to the cylinder. We don't need this one anymore, so we can delete it. But we'll go into our cylinders. And we're going to make kind of our donut shape. So as we know, the thread that we made here, so the thread is the design that we have. So the thread, the diameter is around 8-ish, 7-ish, or between probably 7.5 and 6. So we can go ahead and make this a little bit larger. So we're gonna pick the diameter of our circle, and we're gonna make that diameter, maybe we'll give it 23. I want some big wheels on that. So this is gonna be how big our wheels are. And then we're gonna go ahead and make it kind of like a donut shape. So we're gonna take a cylinder that's a hole, and this one we're gonna change it to a diameter that's bigger than the thread that we picked. So I think 7 is probably a good bet. No, we'll do 8 to be safe. Anyway, it's not gonna go anywhere, so. And then now we want to create our donut shape, so we'll select both and go ahead and align them. Again, in the middle and in the middle. And once we've got that, we can just go ahead and group it. We've got our donut. And we'll just make our beautiful donut just a little bit less tall. We can go overhead, put 10 here. Maybe even smaller, actually. Wheels on a race car usually aren't that. So we'll do, I think 5 should get the board across. There we go. And we're gonna need 4 of those because there are wheels, so we're just gonna copy paste them until we've got 4 of them. Oh, there we go. So now, now that we've got our shape, we will be able to align the wheels on. So if we select both the wheel and the bolt, we'll be able to align them. We'll be able to align the wheel with the bolt. Not quite. I think we need to flip our wheel first. So we'll just grab it and give it a flip as we've done before. and just do it at 90 degrees. And now we should be able to go ahead and align. Well, seems like it's giving us a tough time. So instead of doing that, I'm actually gonna just go ahead and place my wheels where I'd want them to be. So I'd want them a little bit higher. There we go. We'll have to make this a little bit bigger again. I apologize for the wrong dimensions on here. It's a little bit tough if you're using an online found template because you'll never know if it exactly fits your needs, but you can get like an approximation. So we'll go ahead and we'll do that for the other ones as well. We'll flip them over and just go ahead and place them where we want them to be. And just make sure that our bolt is going through them. And we can do the same on the other side. Alright, and there we go. Alright. And there is our lovely car. We can add on some nuts over here to make sure that those wheels would stay on perfectly, but this is our race car here that we have today. So if you wanted to go ahead and print this piece, unfortunately you wouldn't be able to do it all in one go. You'd have to print the separate pieces one to one in order to get all the pieces and assemble the car afterwards. Just because if you told the machine to print this, go ahead and print this, because it prints by layers, it wouldn't be able to do it properly. It wouldn't be able to be a successful print. As if you tried to put the layers through, it just wouldn't be precise. It would end up kind of probably a bit of a gooey mess inside, as it would try to defy gravity. So it's always really careful to take into consideration when you're making a 3D model to print, how you want to print it and what's most efficient. So there we go, that's our car for today. I hope you enjoyed, and I will see you later for the French stream at 2:30.